Hello everyone and welcome. Today we're going to get into some really powerful mathematics. This isn't just theory. This is the practical, hard-hitting math that business leaders use to answer their single most critical question. How much should we produce to make the most money? Understanding this is what separates a good business strategy from a great one, and it can literally be the difference between a company that thrives and one that fails.
So here's our roadmap for today. We're going to start with a question that every single business has to ask itself. Then, we'll dive into the math and decode the story that quadratic functions tell us. After that, we'll get our hands dirty with 3 real-world case studies, finding maximum revenue, then minimum cost, and finally, the big one, hitting peak profit. To wrap things up, we'll talk about the final decision and when a leader might just dare to go against the numbers. Let's get started.
All right, let's kick things off with the question at the heart of every business, whether you're running a food truck or a multinational corporation. The question is simply, how many should we make? It sounds so basic, right? But the answer is the balancing point for the entire company. If you get it right, you're on the path to success. But if you get it wrong, well, you could be risking everything. This isn't just an operational question. It's the absolute core of your business strategy.
We're looking for what we call the sweet spot. It's that perfect point of equilibrium. See, if you make too few items, you're leaving money on the table. You have customers who want to buy, but you don't have the inventory. On the other hand, if you make too many, you run into a whole different set of problems. Your costs go up, and to get rid of all that extra product, you'll probably have to slash your prices. When that happens, your total revenue can actually go down, and your profits just tank. So the goal is to get beyond a gut feeling or a guess and find a precise data-driven number. And the key to finding that number is a shape you all know from algebra class, the parabola.
Okay, so let's get into the mathematics here. The quadratic function, you know that standard ax squared plus bx plus c form, it's way more than just a formula you have to memorize. In a business context, it's a narrative. It tells a story. Think about it. As you increase production, which is our x-axis, your revenue goes up at first. But eventually, you hit a tipping point. Maybe the market gets saturated or you have to cut prices, and that beautiful upward curve starts to bend back down. That whole journey, the rise and the fall, is captured perfectly in that simple, elegant curve of a parabola.
So, with that in mind, our entire analysis today, everything we're about to do, it all comes down to finding one single, incredibly important point on that curve. And that point is called the vertex. Now write this down, highlight it. The vertex is the highest or the lowest point of the parabola. It's the peak of the mountain or it's the bottom of the valley. In business terms, this is the turning point. It's the exact number of units you need to produce to hit your goal, whether that's maximizing profit, maximizing revenue, or minimizing your costs. Finding this point is everything.
Now, I really need you all to pay close attention to this slide, because this concept is fundamentally important. Before you even think about touching a calculator, you can tell the entire story of your business model just by looking at one thing, the sign of the a coefficient. That's the number attached to your x squared term. If a is negative, your parabola opens downward, like a hill. That means its vertex is a maximum point, which is perfect when you're modeling things like revenue or profit. But if a is positive, the parabola opens upward, like a valley. Its vertex is a minimum point, which is exactly what you'd want if you're trying to minimize your costs. This is your first, absolutely crucial reality check to make sure your model even makes sense.
And this wonderfully simple formula is the key that unlocks the whole thing. X equals negative b divided by 2a. This little formula gives us the x-coordinate of the vertex. In our world, x is the quantity of units we need to produce. The a and b values, of course, come straight from our quadratic function. Just remember, a tells us if we're looking at a hill or a valley, and b helps position that curve. This formula puts it all together to pinpoint that exact turning point. This is the tool we're going to be using from here on out.
All right, enough with the theory. Let's put this into practice and get our hands dirty. We're going to start with our first case study, which is all about a very common business goal, maximizing total revenue. We've got a revenue function, and our job is to find that perfect production level that brings in the most cash. So here it is, our revenue function, r of x equals 500x minus 0.05x squared. Now, before we do a single calculation, what is the very first thing we do? That's right, we inspect that a term. I've rewritten it here in standard form so it's easier to see. A is negative 0.05. It's negative. So what does that tell us? It confirms our parabola opens downward, which means we're looking for a maximum. Since our goal is to maximize revenue, this model is perfectly set up. We're on the right track, and we can move forward to find the peak of that sales hill.
Okay, now we just follow the procedure. Step 1, identify your variables. From our function, a is negative 0.05, and b is 500. Simple enough. Step 2, We plug these directly into our vertex formula. Now listen, I'm going to stress this. Be meticulous with your negative signs. This is where so many simple, frustrating errors happen. The formula becomes x equals the negative of 500 divided by 2 times negative 0.05. Step 3. Let's simplify that denominator. 2 times negative 0.05 is negative 0.1. So now our equation is much simpler. X equals negative 500 divided by negative 0.1.
And that brings us to our answer. A negative divided by a negative is a positive. 500 divided by 0.1 is 5,000. And there you have it. The optimal number of units to produce to maximize our total revenue is exactly 5,000. It's not around 5,000. It's not 4,999. The math tells us the peak is precisely at 5,000 units.
So I want you to picture this. You're in a strategy meeting. Your VP of sales is all fired up and says, "Team, let's push production to 6,000 units this quarter. More is always better." Now you can step in, and you're not just offering an opinion, you have the data. You can confidently say, "Actually, our analysis shows that peak revenue occurs at exactly 5,000 units. If we push to 6,000, we're going to have to lower prices so much that our total revenue will actually start to shrink. The math shows that 5,000 is our revenue sweet spot." That right there is how you use math to make a powerful business argument. That's how you become invaluable to an organization.
Okay, let's take a quick timeout. Professors aside here. I want to talk about the common mistakes I see students make with this, semester after semester. First, and this is the biggest one, forgetting that little negative sign in front of the b in the formula. It is so easy to overlook, but if you forget it, you're going to get a negative answer for your quantity, which makes absolutely no sense in business. That should be a huge red flag that you've made a mistake. Second, make sure you're correctly identifying a and b. A is always the coefficient of the x squared term. It doesn't matter what order the function is written in. And finally, and this is a big one, remember what x actually is. Our formula solves for x, the quantity of units. It does not tell you what the maximum revenue is. To find the actual dollar amount, you have to take your answer for x, in our case 5,000, and plug it back into the original revenue function. Avoiding these pitfalls is absolutely crucial.
All right, let's move on to our second case study. This one is about minimizing cost, but there's a really interesting twist here. This example is going to teach us a critical lesson about making sure our mathematical model actually matches our business goal. This is where you have to be more than just a human calculator. You have to be a critical thinker.
Okay, class, I want everyone to look very closely at this cost function. Before you do anything else, I want you to apply that first critical step we talked about. Look at the a term. It's negative 0.02. It's negative. A giant red flag should be going up in your mind right now. A negative a means this parabola opens downward, right? And that means its vertex is a maximum point. But wait a minute. Our business goal is to minimize cost. This model, as it's written, is designed to find the point where our costs are at their absolute highest. This is a perfect example of a flawed model, and it shows you exactly why that initial check of the a term is so unbelievably important.
So, even though we know the model is flawed for our stated purpose, let's go ahead and run the calculation anyway. It's important to understand what the math is telling us, even if it's not what we're looking for. So a is negative 0.02 and b is 50. We plug that into our formula. X equals negative 50, all divided by 2 times negative 0.02. That simplifies to negative 50 over negative 0.04.
And the math, of course, gives us a clean answer, 1,250 units. The calculation itself is perfect. But the real question for you, as a future business analyst or manager, is not, what's the number? The real question is, what does this number actually mean for our business in this context?
And here is that critical interpretation. This number, 1,250, represents the production level where the company's cost is maximized. It's the absolute worst-case scenario. This is such a powerful lesson. That simple 1-second check of the a-term sign at the beginning would have saved you from making a recommendation that could bankrupt the company. A realistic cost function would almost certainly have a positive a-term, creating a valley. Why? Well, because of economies of scale. As you start producing more, your average costs go down, but only up to a point. Then, things like machine maintenance, overtime pay, and logistical headaches kick in, and your average costs start to rise again. That's the valley shape. Your model has to reflect that business reality.
And that brings us to our final case study, the main event. Because while high revenue and low costs are great, the number that really matters, the ultimate goal for any for-profit business, is profit.
Remember, profit is just revenue minus cost, so its function captures the push and pull of both of those dynamics.
So let's take a look at our profit function here. What's our first check? You got it. The A term is negative 0.1. It's negative, so that means our parabola opens downward, and we're looking for a maximum point. Now, is that what we want for profit? Absolutely yes. The model is correctly structured. We are looking for the very top of the profit hill, and we can move forward with confidence.
By now, you all should be pros at this. We're just following our same reliable steps. Step 1, A is negative 0.1, B is 40. Step 2, we plug them into x equals negative b over 2a. That gives us negative 40 divided by 2 times negative 0.1, and step 3, that simplifies down to negative 40 divided by negative 0.2.
And there it is, the number that every CEO, every board of directors, every shareholder wants to know. The math tells us, with certainty, that producing and selling exactly 200 units is the absolute sweet spot. That is the point of maximum profitability for this company.
So let's step back and think about why all of this matters. The whole point of this exercise is to transform business decisions from ambiguity and guesswork into clarity and precision. Instead of just having a gut feeling, you now have a specific defensible target. This one number, 200, can drive your entire operation, your production schedules, your raw material orders, your sales targets. It moves the most important decisions a business can make out of the world of intuition and into the world of mathematical certainty.
So I want to leave you with this final and very important thought. We've proven today that math gives us a clear, powerful tool for finding the optimal path. But I want you to remember as you go out into the business world that decisions are not made in a purely mathematical world. What if, for example, a new competitor is about to enter the market? Maybe the right strategic move is to produce more than 200 units, even if it hurts short-term profit, just to gain market share. What if your long-term goal is brand dominance, not immediate profit? The math gives you the data, the baseline, the point of pure financial optimization. But true leadership is about knowing how to weigh that number against your long-term strategy, against market risks, and yes, against your own expert intuition. The challenge isn't just finding the number, it's knowing when to follow it and when to have the courage and foresight to choose a different path.